Alright, this morning we're continuing with our other big idea for this unit, developing number sense and demonstrating an understanding of factors, multiples, and prime and composite numbers helps us to describe and to solve problems. So factors, really, you know a lot about already. Factors are numbers that multiply to equal a given number. So, for example, we are going to look for factors of 9 and 15. So, factors of 9 are 1 and 3. Now, they have you using a Venn diagram. You're welcome to use that if you'd like, or you can just list them. So we know that 1 times 9 equals 9, and 3 times 3. We only have to write the 3 once. If you really want, you can write it twice. It really doesn't make a difference. But remember that 1 and 9 and 1 are really the same thing. So it only counts as one. You don't have to write them twice. Factors of 15 then are 1 and 15 multiplied to equal 15, and 3 and 5. And you need to try to find them all. The key with factors is finding all of the ways that you can multiply. It's not like multiples where it could go on and on and on. Factors have a definite number of factors, and you need to make sure you've gone through your multiplication facts in order to find all of them. If you don't have all of them, it messes up your common factors and such. So common factors then of 9 and 15, and remember common are ones that are the same. So we have 1 and 3 that are common, and those would be our common factors. And if you did it in a Venn diagram, the common ones, of course, are the ones that are overlapping there. One of the most successful ways that I have found to write a product of factors, write a number as a product of its factors, is to use a factor rainbow. So here we have factors of 45. 1 and 45 are multiplied to equal 45. 3 and 15 multiplied to equal 45. And 5 and 9 multiplied to equal 45. So we have them as a rainbow so that we are making sure that we have all of the ones that we can find. So to look through, we would think, okay, well, does 2 times anything equal 45? And you could try that on your calculator. Try 45 divided by 2 and see. We could also consider our divisibility rules. What do we know about numbers that are divided by 2? Well, they have to be even. So do we really have to try 45? Not really. We know for sure 45 is going to be divided by 5 because it ends in 5 or 0. Anytime we divide by 5, it has to be for a number that ends in 5 or 0. So we can consider our divisibility rules to help us with this. One of the key things when you're doing your factors is to make it systematic. So make it like a list of some sort. That's where the factor rainbow works really well. You are less likely to make errors if it's in a systematic fashion. So 45, okay, I'm thinking of 45. 45 divided by 1. Well, always 1 times the number itself. 45 divided by 2, I'm thinking in my head, well, I know it's not an even number, so that's not going to work. 45 divided by 3, well, let's try that. I might have to punch that into my calculator if my basic facts are a little bit weaker. 45 divided by 4, again, with 4, it has to be an even number. That's not going to work. 45 divided by 5, oh, for sure works. Ends in 5 and 0, and so on. And keep going until at least 9. And then if you've gone all the way through 1 to 9, you probably have them all. All right, and then of course we can link that to prime and composite numbers. So some of your factors are prime numbers. Are prime numbers, and some of them are composite numbers. So remembering what we know about prime and composite numbers, prime numbers are only numbers that can be multiplied by 1 and themselves. So for example, 7 is a prime number because we can only get 7 by multiplying 1 times 7. We can't find it any other way. 9 is a composite number because we can get 9 by finding it by 1 times 9 and 3 times 3. Really important to remember that it's always times the operation that we're using, not adding, not subtracting. It's always, always times. Now we're going to move on to what we call a factor tree. So this is a way that we can show the number 45. All right, so we are going to show 45 as a product of its prime factors. Okay, we can also call this prime factorization. So two names, product of prime factors. Because product, remember, means multiplying, and prime factors, all of the factors, the numbers that would multiply, that are prime. So that's one way we would call it, one way that we could call it. We could also call it prime factorization. So when you see either of those, oh, sorry, running out of room here. That's meaning we're trying to do this or this, okay? So, in order to do this, what we do is we look at 45 and we say, okay, two numbers that multiply to equal 45. And it can be anything but 1 times itself, because that really doesn't change anything. Okay, so we've decided on 9 and 5. So 9 times 5 equal 45. And then we decide, okay, 5 can be multiplied by what? Well, it's already prime, so we just bring it down. It stays down, 5. Important to make sure you bring it down. 9 is not prime yet, so we're going to keep going. Well, 3 times 3 makes 9. So now we look at these last numbers, and these are all prime. 3 is prime, 3 is prime, and 5 is prime. So as a product of prime factors, 45 would be exactly this, 3 times 3 times 5. And if you try that, 3 times 3 is 9, 9 times 5 is 45, it does equal 45. So by multiplying these, finding the product, multiplying these, all of these prime numbers, we can in fact find 45. So this is 45 as a product of prime factors, or the prime factorization of 45. We can do it a slightly different way. We could do what we call upside down, or what we call repeated division. So we could say, okay, 45, I need to divide it by a prime number. This number has to be prime in order for this to work. So my first prime number I'm going to divide it by is 3. It equals 15 here. Then I'm going to divide it again by a prime number. My answer now, what it was 15. So I'm taking 15. I have to divide it by a prime number. So I'm going to go by 3, which equals 5, which is fine. And then I have 5 left. So I'm going to see if I can divide 5 by a prime number. Well, I can. It's 5. And my final answer should be 1. So now I know that these numbers, 5 times 3 times 5, does give us 45. Okay, sorry, 5 times 3 times 3 is 45. So that's product of prime factors. Really important, this is the final answer. You need to have that part, otherwise it's not considered complete. Okay, you cannot just have this work. You need to have the final equation with the multiplication signs in between, because as a product, we need to be multiplying, and it has to have all prime factors. So all of these numbers have to be prime. If they are not prime, you're not done. You've missed a step. Go back and check. All right, at this point, you're going to practice. You are going to use any strategy of your choice to find all the factors of this number. So I would recommend factor rainbows, but you can use whatever strategy you choose for all 3 numbers, finding all of the possible factors, not missing any of them. Press pause and try that now. All right, let's take a look and let's try that, okay? So we had 8. So all of the ways that we can make 8. Well, I know for sure 1 and 8 make 8, so I'm going to have those, and I'll join them. 2 times anything equal 8. Yes, 2 times 4 equals 8. And I'm going to separate those with a comma so it doesn't just look like one big number. Okay, so make sure you do that. Separate those with a comma. Then I'm going to think 3 times 8. Well, 8 is even, so it's not going to be 3. Or I suppose it could be, but it isn't in this case. 4. We already have 4. 5, no, it doesn't end in 5 or 0. 6 6 times nothing equals 8. 7, no. 8, well, 8 times 1, which we have already, and 9, nope. So I've got them all, okay? Let's try 33. Well, I know 1 times 33. 2 times anything equals 33? No. 3 times anything equals 33? Actually, yes. 3 times 11 equals 33. Okay. 4 times anything equals 33. Well, this is where I could punch it into my calculator. 33 divided by 4. Nope, there's a decimal. It doesn't work. 33 divided by 5. 5 times anything. Well, it doesn't end in 5 or 0, so no. 33 divided by 6. Ooh, that's possible. But if I think in my head, 6 times 5 is 30, and 6 times 6 is 36, so yeah, that's not going to work. 7 times anything. Well, 7 times 5 is 35. No, that's too big. 7 times 4 is not 33. No, that doesn't work either. 8 times anything. 8 times 4 is 32. 8 times 5 is 40, so no. 9 times anything. Well, 9 times 4 is 36. That's too big. 9 times 3 is 27. Nope, that doesn't work either. So those are all of my factors for 33. Lastly, we'll try 32. Oops, I need my pen. 32. Again, 1 times 32 works. 2 times something should work. It's an even number, so it should work. And if you need to, feel free to pull out your calculator. 32 divided by 2. Oh, well, that's 16. So 2 and 16 works. 3 times anything. Well, 3 times 10 is 30. 3 times 11 is 33. No, that's not going to work. 4 times anything. 4 times 8 is 32. Perfect. That's my next one. Oh, I hope I don't have a whole lot more. I don't have a lot of room. 32 divided by 5. Nope, doesn't end in 5 or 0. It's not going to work. 32 divided by 6. Well, 5 times 6 is 30. 6 times 6 is 36, so no. 32 divided by 7. I had 7 times 5 being 35. 7 times 4, no. 8 times something, well, I have that already. And 9. 9 times 4 is 36. That's too big. 9 times 3 is 27, so that doesn't work either. So now I know I have all of the factors of 32. All right, now we're going to try factor trees. So if I have a factor tree for 27, I need, oh, sorry, my pen. I need 27, something times something that's 27. And again, it doesn't matter, but it can't be 1 times 27, because as you can see, that changes nothing. I still have to work with 27. It's just adding an extra step that means nothing. So we don't want to do that. So I need something times something that is 27. Well, I know 3 times 9 is 27. So I'm going to start with those. 3 is already prime, so I can just bring it down. 9 times something times something, that's 9, and it's not 1 times something, has to be something different. Well, I know 3 times 3 is 9. Sorry. So, and now 3 and 3 and 3, they're all prime numbers. I've got all prime numbers. I'm done. 3 times 3 times 3 equals 27. That is showing it as a product of prime factors. Remember, you need to have this final equation. You also need to have all of this work. As always, always, always in math, I want to see evidence of your thinking. You need to show your work as evidence that you have been thinking, what you've been doing. It's much more helpful to find mistakes, and it also proves that you're doing the work and that you're understanding it and what's going on in your head, which is really important in the new math curriculum. All right, let's try 60. If you haven't already done it, press pause and do so now. All right, 60. Oops, I need my pen. 2 numbers that multiply to equal 60. Well, the first 2 that come to my head are 6 and 10, so I'm going to start with those. Now, neither of those are prime, so they both have to be worked on. 3 and 2 multiply to equal 6. And 10, I have 5 and 2 that multiply to equal 10. 3 is prime. 2 is prime. The only way I can get 2 is 1 times 2. It is the only even number that is prime. And 5 is also prime. So I found all of them, but I'm not done. I need to make sure I include my number sentence. 3 times 2 times 2 times 5 equals 60. And remember, those are multiplication signs, not adding, so do be careful. All right, and now you're on to the concept practice. Remember, this concept practice allows you to practice the skills. It is homework, and we will mark it and discuss it together. So this is out of the textbook, and you are working on page 65 and 66, numbers 2, 4, 5, 8, and 10, and you are working on demonstrating an understanding of factors and common factors, and also probably some product of prime factorization, since we did that as well.